Now, in order for us to add our objects in as documents to our collection, we're going to do it very similar to how we did it inside of our create user profile document function. We're going to create the reference document object, and then we're going to set it using .set. Now, the thing about Firestore is that we can only make one set call at a time. We can't actually say, for example, call collection ref .set and then set an array of values in as the collections documents. But that's okay. We can just write code that will do that for us. But the thing to consider is that because each call is individual, they fire one at a time. If our internet connection, say, stops halfway through, our code only will have saved half those documents because the other half would not have made it to the server. Now, this is bad because our code becomes unpredictable. We want to know that if we hit our function and all of our requests send, all of them should set. If any of them fail, we want the whole thing to fail because then we can anticipate that, right? We know that our code is consistent. So in order to do that, we have to do what's called a batch write. And a batch write is essentially just a way to batch or group all our calls together into one big request. So here's how we're going to do it. It's actually very easy with Firestore because Firestore gives us what's called a batch object. And with this batch object, we just add all of our, for example, sets into it, and then we fire it off whenever we're done adding all the calls we want to it. And what we'll do is we will loop over this objects to add array using our for each method. And what this for each array method is very similar to the map method. The only difference is that for each does not return us a new array, the same way that .map does, which is great for us because we only want to call the function on each element. And we'll get the object, and what we'll do is we will create a new doc reference, which is equal to our collection ref at .doc, right? So what this means is that we want to get the document at an empty string. So what this will do is it's telling Firebase, give me a new document reference in this collection and randomly generate an ID for me. So we'll actually see it if we console log this. If we save this and we go back to our app, we'll see that we logged 5 document reference objects, and each one points to its own unique ID. Because we're telling Firestore that in this collection, I want you to make me new document reference objects, but create your own key. For example, what we can pass is our object title value. And now if we save, we will see that the ID inside of our document is our title on our object. But we want this key to always be unique. So we'll just let Firestore set it for us. And then what we need to do is we need to actually set the value using our new doc ref. The only thing is that we want to batch it at this point. So instead of calling new doc ref .set, we're going to call batch.set. And what we'll pass it is the document reference and the value we want to set it to. So we want to set it to the object. And that's all we're going to do. We're just going to loop through this array and batch these calls together. And then what we'll do is we want to fire off our batch call. Now, what we need to do that is call batch.commit. And .commit will fire off our batch request. But what it returns us back from calling .commit is a promise. When commit succeeds, it will come back and resolve a void value, meaning a null value. And that's useful for us because if we call this function somewhere, we can chain off this function and then call .then and do something if this call succeeds, or we can handle errors as well. So we need to return this from our call, but we're going to make this an async function because we're doing an asynchronous request. So we will return await batch commit. Now, before we save this file, we do have to remember that this collection does hold values that we don't want in our database, like the route name and the ID, because we're asking Firebase to generate them for us. So what we can do is we can actually say inside of our app.js, instead of passing the full array, what we'll pass in is a new array where we get the object and we are going to destructure off of it the title and the items. So just the properties we want. And then we'll just return a new object where title goes to title and items goes to items. So this collections array.map will be returning us an array of just objects with the values that we want to keep. And now if we save in both files, if we go back to our Firebase application, we'll see that we have our new collections with the items inside. And these items have exactly the fields that we're looking for. They have the title and they have the items. So now that we've stored our documents inside of our collections, we can remove the code from our app.js. So we need to get rid of all of this code that we had added into our app.js component did mount. Now, the reason we want to do this is because, as we mentioned, we just wanted to programmatically add our code of our shop data into our Firestore. But after that's done, there's no reason to keep that code inside of our component anymore. But the good news is that we do have this function that we can use to make new collections and documents whenever we want. So now what we got to do is we need to pull our data from this collection into our application and then store it inside of a reducer instead of just setting it as the initial value in our shop reducer right now. So let's see how we can do that.